Hey guys, so here we are. This is my Say It With Symbols lesson 3.3. We're going to look more at factoring quadratics. We did practice this yesterday, but this is the book work that we'll be completing. Okay, so let's start here. Tell me what can we tell about this equation? So y equals x squared plus 5x. We know that there's x and it's squared, so that means it's quadratic. We also know x and y are variables, meaning that they can change. So anytime you plug a number in for your x, you would be able to solve for y, or vice versa, okay? The other thing that we notice too is that we can factor this equation. So I'm going to go ahead and do that here. I'm going to take out the x, which is the common term of common factor for each one, and so it's x times x plus 5. Okay, so the opposite of distributive property tells me that this would also be y equals x times x, so x squared plus x plus 5x. Okay, but it's actually the factored format that we're going to look at that's going to help us with today's lesson. Okay, so here we go. Sometimes mathematical problems that appear to be different are actually the same. Finding the x-intercepts of the graph of y equals x squared plus 5x is the same as solving the equation x squared plus 5x equals 0. So here we have that equation x squared plus 5x set equal to 0. That's where the x-intercepts of the graph are located. So the solutions to x squared plus 5x equals 0 are also called the roots. These are the intercepts, okay? And in Frogs, Fleas, and Painted Cubes, you found the solutions or roots by using a table or a graph of y equals x squared plus 5x. So let's take a look at that, okay? So again, I'm going to write the factored version of that equation down here. We know over here, okay, so we know that y equals x times x plus 5. Okay, so this is the graph and table for that equation. Well, here in the table, you'll notice that when y is 0, x is negative 5. You can also see that here on the graph, right? So that's the parabola here. It's smiling. It's a positive equation. And the place that it intersects the x-axis is at negative 5. Okay, and then the same one for 0. When I plug in 0 to the equation or set the equation over here equal to 0, I can solve and realize that 0 would be the x value and 0 would be the y value. So again, that's the x-intercept here, okay? So we're seeing both those things in the equation and in the graph. And you should also remember that if you have the x-intercepts for a quadratic equation or parabola, it makes it easier to graph. It gives us a lot of information about the data that we're dealing with. Okay, so how do we know what these solutions are in the equation? Well, let's take a look. So y, hopefully you'll remember this, y equals x and x plus 5. Both of these show us the solutions here, okay? It's presumed that there is a 0 over here, or there's no value over here. So when x is 0, y is 0. Those backwards, I apologize. So that's the one coordinate here that you're seeing. And then over here, you look at the value here, and we notice that that's the opposite of positive 5. So when x is negative 5, y is 0, okay? And both of these are the values for the x-intercepts that you see in the graph. Let's look at an area model. We haven't seen these in a little while. So does the model represent x squared plus 5x plus 6? I'm reading the first question here. It does, because we're going to add up everything inside this model. So it's x squared plus 3x plus 2x plus 6. Combine like terms gets me x squared plus 5x plus 6. Okay, so yes, it does represent that. So what are the factors? Well, let's look at the different way of doing factored equations. I had you practice it yesterday, and I want you to see what it looks like in an area model today. So I go ahead and write on the outside what's going on the inside. So I have an x value here and an x value here. I know multiplied out, that would get me x squared. And then I have a 2 here because I know 2 times x is 2x. And then I would have a 3 here. I know that x times 3 is 3x. And lastly, 2 times 3 is 6, okay? So I'm going to take this information from my area model and I'm going to write the factored version of the equation. This is just another way to do it. Okay, so here's the factored version. Y equals x plus 3, x plus 2. Okay, and so now what are the x-intercepts of the graph? Well, you're just going to look at these two values here in my factored version, and you're going to say that this one here, the first one, would be -3, or the opposite of that value there, -3, 0, and then I have -2, 0, okay? So when y is 0, my x values are -3 and -2 for this parabola. So what is the relationship between the x-intercepts of the graph and the factored form? Well, we notice that when we factor this equation, we can go ahead and find the x-intercepts here. So let's practice factoring a couple more times. Okay, here what we practiced yesterday in the Khan Academy videos, I'm going to look at this value 12 here, and I'm going to write down all my factors for it. 3 and 4, 2 and 6. Then I'm going to look at these number combinations and figure, well, which ones add up to 8? And the reason I'm adding is because all these numbers here are positive. So it's actually 2 and 6. They add up to 8 nicely. So factored out, this would be y equals x plus 2 times x plus 6. Okay, so here I have a version. So I want to show you how to check your answers in case you need to. This is distributing quadratics using the FOIL method we learned in Frog, Sleeves, and Painted Cubes. So if I'm going to FOIL this out, I'm going to look at the first values, which is x times x. I'm writing this in expanded notation for you. The outside values, -3 times x. Inside values, 3 times x, positive 3. And then 3 times -3 is my last value. Okay, so let's simplify this, and let's say it's x squared plus -3x plus 3x plus -9. I'm going to get rid of these double negative positive weirdness things here. Notice that -3 and 3x cancel out, and so this equation distributed would be y equals x squared minus 9. Okay, so that's a great way to check your work if you're having problems. So here's the focus for today's lesson. We're going to go back to working in the book. I've created a lab sheet for you to fill in and complete. What are some strategies for factoring a quadratic expression? Okay, so this is more of the same from yesterday, just getting a little more practice. Remember, you're factoring and you're also solving the equation. You're finding the roots of the equation, and you're finding the x-intercepts. Okay, so you'll complete problems A to C on my lab sheet attached to the announcement for the day, and you have your books at home if that helps you. Please reach out to me any questions. I'm going to quickly scroll through the answers for this lesson so that you have them to reference. You'll just need to pause this video if you need to look through them. Okay, so good luck today. Hope you guys are well.